Hey there, welcome to my channel on chemistry lessons, and predominantly at the moment they are focusing on BTEC Applied Science and AQA A-level. Go ahead and subscribe so you don't miss any future ones. Aim is in the future, before we get to exams, is that we'll do some short snappy revision videos that will cover the key concepts for exams. This is a BTEC Applied Science lesson, and it's chemistry. It's going to cover assessment objective A2, and we'll talk about what those mean in a minute, but this is lesson 5 so far, so there's 4 previous lessons, and this lesson focuses on period 2 and period 3 elements reacting with oxygen. So we look at all the elements in periods 2 and 3 and their reactions with oxygen. So when it comes to the Unit 1 external exam, this is the chemistry section, section A. B is biology, C is physics. There are 2 learning aims, and this series of lessons is to cover the second learning aim, which is that production and use of substances in relation to properties. Doesn't really give too much away there. And that's the entire list there. Okay, the first 4 videos that we've done we've looked at all of this, and we've looked at all of these all the way down. So the first 4 videos have in fact covered all of these objectives. So all we've got left to cover are these sections here. Okay, and this video is only going to focus on the very first bullet point. So we're going to focus on the products and reactivity of all period 2 and 3 elements with oxygen. So that's quite a lot of reactions. Okay, so we've got to look through each one in turn. We're going to try and find a pattern to make it easier to remember. But what you're going to do in this lesson is, I suggest that you get yourself some flashcards or a piece of paper, whatever, and you can fold your paper up into sections, make yourself some kind of revision cards, because ultimately when it comes down to this, yes, we try and look for the trends and the patterns, but ultimately we just need to know the reactions and the products formed when they react with oxygen. Okay, so those are the key things: the products that we get and the reactivity. Future videos are going to look at the remainder of this course. So periods 2 and 3 then. So what we're looking at is periods 2 is lithium across to neon, and period 3 is sodium and across to argon. So we're not looking at any of these. We're not looking at anything else. We are looking at all those elements from lithium across to neon and sodium across to argon. Okay. Now, before we start, it's probably worth reminding us that these 4 are all metals. So we've got some metals here. Aluminium is also classed as a metal, but you're going to see something today that shows how close it is to that border, because we do have that metal, non-metal border that runs down there. So aluminium is classed as a metal, and the rest, boron, and all the rest of these elements from period 2 and 3 are all classified as non-metal. So we're looking at all of those reacting with oxygen. So the best thing for us to do then is to look at each group in turn. So we're going to look at group 1 and group 2 because they're metals. We identified those in the periodic table as metals. Now, when metals react with oxygen, you get metal oxides. So if I look at group 1, let's just look at group 1. Group 1, for example, we've got lithium and sodium. Those are the 2 group 1 metals. They will react with oxygen to form metal oxides. And to balance the equation, we need to put a 4 in front of the Li and a 2 in front of the LiO2. Sodium will react in the exact same way, so we'll have the exact same equation for sodium. But in fact, sodium is more reactive. Okay, so this is more reactive. So this is a very vigorous reaction, the sodium one. And lithium is vigorous, which means it's reactive, but not as reactive as sodium. And for lithium, we will see a red flame. And for sodium, you will see an orange flame. So when you're making revision cards here, we're looking at group 1. This is group 1 with oxygen. And we only need to look at the first 2. It's only periods 2 and 3. So those are our observations. Okay. Now, further things to consider at this point is that these two products, because it does say in the spec that we need to know about the products, these two products will easily or readily dissolve in water, so they are easily soluble, and when they dissolve you will make hydroxides. They will form soluble and they will form hydroxides, which are very strong alkalis. So group 1 are known as the alkali metals. You may recall that from GCSE. Okay, now group 3 is a bit of an awkward one because this lies on the border where you've got boron and we've got aluminium. Now they will both react in the same way, in fact. Okay, they look similar. They will both react in a very similar fashion. Aluminium being more reactive, so this is actually a very fast reaction, the aluminium. Aluminium is very fast. Boron less so, so the aluminium is more reactive. Boron though is classified as a non-metal, and therefore this is a giant covalent, so we get a covalent structure here. Okay, this would be classed as a giant covalent, whereas aluminium oxide, being a metal, is actually an ionic. So aluminium oxide is ionic. Okay, so that's an awkward one because it's on the metal non-metal border. Boron being a non-metal and aluminium being a metal. So aluminium reacts in a similar fashion to what you've seen with the metals to make a metal oxide, which is ionic. Boron will react with oxygen to make a giant covalent structure. Okay. Now, we also need to look at the properties of these. Now, the rule is metals will form oxides that are alkalis or bases. We saw that with group 1 and group 2. Group 1 and group 2 oxides were alkalis and bases. So, aluminium is also a base. It's a metal oxide. It's a base. However, the non-metal oxides, they are acidic. So you can see the non-metal oxide is acidic, the metal oxide is a base. Okay, making this a bit more awkward though, because it's right on that border, aluminium oxide actually acts as an acid as well, which is really, really confusing because aluminium oxide is acidic and a base. Okay, and in chemistry we use the term amphoteric. So aluminium oxide is amphoteric. That means it acts as both an acid and a base, which is very, very rare. Okay, so in your revision card for aluminium, it's a fast reaction with oxygen, forms aluminium oxide, which is an ionic substance, and aluminium oxide is amphoteric, which means it acts as an acid and as a base. Okay, and your revision card for boron is that boron's a non-metal. It will form B2O3, which is giant covalent, and it is acidic. B2O3 is acidic. Moving on. So group 4 this time. So group 4, we're looking at carbon and silicon. Now carbon will react with oxygen to make carbon dioxide. That should be a very, very familiar one. Okay, and that's a simple molecule. It's a gas. This is a gas. It's in fact a greenhouse gas. Okay, and carbon dioxide, being a non-metal oxide, is actually acidic. So non-metal oxides are acidic. You've seen that on the last page with B2O3. So CO2 is acidic. Silicon will make silicon dioxide, which actually is giant covalent, as in sand. So SiO2 is giant covalent, but you guessed it, it will also react with alkalis. It's acidic. Okay, so we've got acidic, giant covalent and acidic. So revision cards again, carbon with oxygen, carbon dioxide, which is an acidic. It's a simple molecule, it's a gas. Silicon with oxygen makes silicon dioxide, it's giant covalent and again acidic. With it being giant covalent, that means it is in fact a solid. Group 5 with oxygen then. So group 5 here, we've got nitrogen and phosphorus. Now, these are simple covalent structures, but we get mixtures of products here, okay? So I'm not going to give one simple equation, I'm going to give the possibility. So nitrogen will react with oxygen to form either NO, NO2, and N2O5. Okay, so we get a mixture here. And in fact, nitrogen is actually very slow to react. It doesn't really want to react with oxygen. It requires a very high temperature and a very high pressure. That's how unreactive it is. It will need a high temperature, and I've written temperature twice. It will need a high temperature and a high pressure. Very slow. But if it does react with oxygen, which it can do in car engines, for example, when you've got sufficient temperature and pressure, you will make a mixture of nitrogen oxides. And phosphorus is far more reactive, so you'll get a white flame, very reactive, or far more reactive. And what you will get is if you've got a small amount of oxygen, you'll make P4O6, but if there's lots of oxygen, you will in fact make P4O10. So this is quite an awkward one, okay? Quite an awkward one. And these are all of these are non-metal oxides, which means they are all slightly acidic. Hopefully you've seen a pattern that the non-metal oxides are acidic, metal oxides are basic or alkaline. Right, group 6 this time then. So again, we get a slight mixture of products. Now oxygen with oxygen, we're not really, we're not going to talk about oxygen reacting with oxygen, but it's possibly worth mentioning at this point that ozone does exist. So ozone layer is O3. The other element here in group 6, sulfur. Sulfur will react with oxygen to make sulfur dioxide, which is a simple molecule. It's a simple molecule and, you guessed it, it's acidic. It's a non-metal oxide. What can happen is if you continue to heat it, it can actually react further with oxygen to make SO3, but again they're both acidic. So your sulfur will undergo reaction with oxygen to make sulfur dioxide gas, which is acidic. It's a simple molecule. The sulfur dioxide can go on further to make SO3. So pop that on your revision card. Group 7, well, group 7, that's your halogens. You've got fluorine and chlorine. Now, they form very, very unstable products. So actually, they don't really react because whatever they form are very unstable and they're not long lasting. So we don't need to worry about equations here. Okay. Now, if they were to form oxides, though, you'd be right in saying that they would be acidic. Okay. So any oxides that form aren't very long lived, but they would be acidic. So that's a simple one there. There's not an awful lot happening. Group 8, noble gases, very, very unreactive. They will not react with oxygen. So make sure you can make a link on the periodic table. You've got some revision cards. So we've seen the 4 metals here. Okay, we've got balanced symbol equations for the 4 metals. They will form basic or alkaline oxides. Bit of a funny one with aluminium because that was amphoteric. It will form aluminium oxide, which is ionic. These 4 were also ionic. However, aluminium being right on that border, it's amphoteric. It will form an aluminium oxide that's basic and acidic. Boron was a non-metal and it would form an acidic oxide. And hopefully, we've just gone through the rest. These are all, if they react, they form acidic oxides. Some react more easily than others. So Nitrogen, very unreactive, whereas phosphorus was more reactive. Group 8 did not react, very, very unreactive. We saw with fluorine and oxygen, they did react, but would form very unstable, but not long-lived, so very unstable and short-lived oxides. And sulfur dioxide being an acidic gas that would react further to make sulfur trioxide. So it is confusing. There is a lot to this, but hopefully with revision cards, you can pick up and you can see the trends in their properties, such as being basic or acidic. Okay, so pick up those trends, get yourself some revision cards written down. Well, that brings this lesson to an end then. Hopefully you've managed to make yourself some nice fancy revision cards. Keep them and use them as often as you can. So the idea of using revision cards is not the fact that you've made them. Revision cards are to be used once a week. Okay, so if you can use those revision cards once a week for 5 or 10 minutes, you'll be amazed at how you will learn those. Okay, so if you've made those cards today, do not just chuck them in the bin, or do not just leave them until the exam, because what's the point? The whole point of revision cards is to short, sharp bursts of looking at them once or twice a week, and you'll be amazed at how much you will remember. Good luck, and I'll see you in the next video.